Good evening, class. Good evening, everyone. Can you hear me?
Yes,
Good
ma'am.
evening.
Good evening, ma'am.
So, like I was following the group chats this afternoon, and it's obvious we already know the reason why we have to have our lecture by 6 because the time that there's no lecture on the timetable. Pharmacy students say they have break time by from between 1 and 2, and they have to observe their break. And because of clashes here and there, this is the best fit for everybody. Um this is a faculty course. It's a course that cuts across faculties. I hope you understand. So I'll be sharing the YouTube link because once this class exceeds 300, people will not be able to join. The Zoom class is for the first 300 people. Now, I will share the YouTube link in the group chat so that the course rep, the course rep can forward to the course rep can forward to the students to chats. And by the way, please inform your colleagues. You every class will have a quiz. That is a means of math attendance. Plus, it will also help to boost your CA. Do you understand? Are we together? I want to be sure, please. I want to be sure you are hearing me when I
No,
talk.
ma'am.
Was no, you don't understand, or you're not hearing me. Which one?
I don't get you, ma'am. Can you please come again?
From where? I said I'll be sending the second link so that when this class is full, the others can with you. That was the first thing I said. The second thing I said was that we will have a quiz in the course of the lecture. I can't say whether it's the end. I can't say whether it's the, but in the lecture notes have been, when it's time for the quiz, we will have the quiz. And we usually submit our response in the group chat. The response is submitted in chat. So did you get it now? Not
Yes,
to,
ma'am. Thank you, ma'am.
so that we do not, uh, and then I also said we have this class by this time because of clashes, interdepartmental clashes here and there. So which is why this is the time for best fit for everybody. I'll be sharing my material now. And today we'll be talking on water. I shared the um course content last class in the group chats. I hope it has been forwarded to your colleagues. We couldn't have our class last week because of the Salah break. So everybody welcome back on board. So today you have to tighten your belt and be ready to work. If I'm going too fast, please let me know because it's time for quiz because it's on today's topic. The quiz for today will be the topic of today. So we are talking about water and biomolecules, protein and carbohydrates. But today we'll just do water and proteins. Good. And what we usually call the universal solvent. And like we did last class, it has the molecular formula H2O. What is H? What is O? Who can tell us? What is H? What is O?
H is hydrogen, O is oxygen.
Thank you. So it has two hydrogens, two molecules of hydrogen and one molecule of oxygen. So there's a question here. Why does water's bent shape matter? Who can Why does the bent shape matter? because the bend shape gives it its angle. That is one of these. And this angle creates a polar molecule with a partial negative charge on the oxygen and a partial charge on the hydrogen. So the bend shape makes it a polar molecule. Polar means it's water loving. And then water exhibits hydrogen bonds. It forms hydrogen bonds with because of its hydrogen atom. And the two hydrogen atom act as an acceptor. If you still remember you remember donor, you remember one donates, one accepts. You should remember your Ulrich. Oxidation is loss, oxidation is gain. Do you remember all those chemistry, all those? Did you do it in chemistry in O levels and 100 level, if I want to believe? So water exhibits hydrogen bonding through the hydrogen atoms it contains. And in the table, the following table shows the property of water. I'd like us to go together. The first line says what? It has what? Property. The first line.
It has a specific capacity, its capacity.
Thank you. That is why it boils at 100 degrees Celsius, if you remember the of water. So the hydrogen bond absorbs thermal energy before breaking. That's the explanation for why it has specific heat capacity. And that's why the boiling point is that high. And for the biological significance, it is temperature buffering in organisms. That means it doesn't allow us to sublime. It doesn't allow us to go into, it doesn't allow the body to be dehydrated because of the high specific heat capacity. Also, it has a high vaporization. It means that many hydrogen bonds be broken down for water to vaporize. That's why human beings can survive harsh temperatures. Also, water surface tension. It exhibits what water has surface tension. What this means is that it forms a capillary action, and these capillary actions allows for stability in the lungs. Then is also a universal solvent. That's actually the definition of water. What universal solvents? Dissolving metabolites, electrolytes, etc. Okay. It also has density anomaly. This the hydrogen bonds form hexagonal lattice. I'm almost gliding over this because we did this last class. For those who remember what we did. The density normally helps it to float on ice. That's why ice floats in water. The next thing we'll be looking at is water as a biological has a hydration shell. What do we mean by hydration? That is, who can tell us what hydration shell is? When NaCl, what is NaCl? What is the common name for NaCl? NaCl is what?
Sodium chloride.
Sodium chloride.
What do we call
Chloride.
it? It's also known as what?
Table
Table
salt.
salt.
Common salt.
Table salt.
My students are very brilliant. So NaCl is salt. So when an ionic compound or a polar molecule, ionic compound NaCl, or a polar molecule like glucose dissolves, water molecules orient around them, forming hydrogen shell. Have you noticed if you put salt, that means if you place salt, you notice that it will now liquefy in a way. Have you noticed? Or glucose. You know, there is this glucose D that they give to people that are fainting, that are hypoglycemic. You know, this glucose. That if you allow air to if you expose it to air, you notice around it, you see some part of it already becoming solus, like water. They already become that is the hydration shell. So water forms hydration shell around ionic compounds or polar molecules. Also, they have ion dipole interaction. As a biological solvent, water's oxygen atom faces cations, hydrogen face anion. So its hydration number is between 4 and 6. 4 and 6, meaning e.g. in sodium you have approximately 4 hydration number, which is dedicated to water. Now, we have an exercise. Let's draw a hydration shell around. What is this? What is K? What is K? What is K? What does that K stand for?
Potassium.
Potassium ion.
Thank you. So you are drawing a hydration shell around potassium ion, carboxylate group, amino group. So I'll just give you, how many minutes should I give you? I'll just give you 2 minutes because I know it's ChatGPT you use, but it's going to record. So around those, draw a hydration shell so that you will know what it looks like. Around sodium, potassium ion, bicarbonate, CO negative means bicarbonate, and then ammonia. H3 is ammonia, an amino group. Okay, so I'll just give us 3 minutes to do that. And by 6:45, I'll just think it's people. People in the waiting room. Are we through? We just have a minute to do that.
Nutrition shell around potassium ion carboxylate.
Please mute your mic. This is a class. Please,
Everybody
mute your
for
mic. Mute your mics. Please mute your mic. Thank you.
No, maybe the brain just clicked today. It's missing you now. It's missing you. Was something on Channels Boy before, but yes.
Ruth Oluwaseun, mute your mic. And another reminder, please forward the Zoom link for those that will not be able to join us. Sorry, forward the YouTube link for those that might not be able to join us on Zoom. I'll forwarded the second link in the group chat. I can't see any response yet. You have to submit it in the chat box for the Zoom or the YouTube, whichever one you are on. You are on this class. You are joining this class from either the chat box of the Zoom or the YouTube. We just have one. In fact, the time is even up. So let's continue. I didn't get any response, and I've noted the time. Okay, so we are talking about a hydration shell. And we said, and I've described to you what that is. Hydration shell is the liquid that forms around glucose or an ionic compound when exposed to air. Now let's talk about the hydrophobic effect. Hydrophobic meaning they do not interact favorably with water. Compounds that don't dissolve in water. Okay, so non-polar molecules like fatty acid chains and hydrocarbons do not dissolve in water. In fact, once you put oil on water, a normal experiment, you see it's floating on the water. They do not mix, they're immiscible liquids. So this creates what is known as the hydrophobic effect. And this hydrophobic effect is useful for membrane formation. That is, in the biological membrane, you have the phospholipid bilayer. Is useful because the hydrophobic layer is outwards and the hydrophilic layer is inwards. If you see the structure of the biological membrane, you have the phospholipid bilayer, which is outermost, and it serves as a sieve. It helps to sieve what goes into the. So that's what keeps us healthy and alive. Now, the next is the protein fold. This hydrophobic effect also helps in protein folding and formation of micelles in detergents and lipid aggregation. The thermodynamics of hydrophobic effects. So this table is showing us the enthalpy and entropy and Gibbs free energy. Delta H is that thing that looks like triangle is called delta. So you have delta H, meaning the enthalpy is negative. That means some hydrogen bonds are formed around the solute. When the energy is negative, when delta H is negative, what does that mean? What does that indicate? That's energy loss. Energy loss. When delta H is negative, that's energy loss. When delta S means energy gain, and that is water molecules are released from ordered cages. Then you have the delta G, the Gibbs free energy. Let's see this. It says here the iceberg model water forms Clatrack-like cages. That means other structures around nonpolar groups. When these nonpolar groups aggregate, the cage breaks, releasing ordered water molecules into bulk solution. Releasing, I'll come again. When these nonpolar groups aggregate, the cages break, releasing ordered water molecule into bulk solutions. This entropy increase, that is delta S greater than 0, drives hydrophobic interaction despite being enthalpically unfavorable. What this means is that once the reaction moves forward, if there is a gain, that is delta S, the hydrophobic interaction results in a bulk solution. That is, there is a gain. Once you see positive, positive means gain. Let's move to the ionization and pH. Water ionization and pH. What does ionization mean? Who can tell us? Who can help us? What does ionization mean? What does ionization mean? Ionization. You don't remember. Ionization is the gain or loss of electrons. Ion, that is electrons. So ionization means gain or loss of electrons. So it also undergoes auto-ionization. You have 2H2O plus 2 hydrogen plus oxygen, giving us hydrazonium ion H3, and then O plus H. Kw is this formula for ionization. K means ionization, W is water. So when you see this formula, K ionization of water is hydrogen ion plus hydroxyl ion equals to 1 times 10 raised to power minus 14. So for pure water, the ionization value for pure water. Please note this formula, just like you calculated what did we calculate in last class? Ionization is very important. It always comes out in every exam. So you'll see things like ionization is just trying to tell you the level of dissociation of a compound. That means a compound dissociating. When you say dissociate, what does that mean? Breaking down. Water will break down into hydrogen ion and what? Hydroxyl ion. Now, what is the ionization energy for water? At 0 degrees, ionization is what? 0.114. And the pH of pure water is what? What's this figure? pH of pure water is what? Are we together? Huh?
7.47.
Thank you.
7.47.
That's for pure water. Thank you. Now at 25 degrees centigrade, Kw, what did I say Kw was again? Ionization energy for water. That is at 25 degrees centigrade. What's the value for Kw? 1.008, and the pH is 7. Please note the table because we are getting to our first quiz. Now, the biological implication is that at the body temperature of 37 degrees centigrade or Celsius and a neutral pH of 6.8, the blood pH is 7.4, which is slightly alkaline. And the pH scale shows this biological relevance. These figures you are seeing here, they are extremely important because any alteration in the blood pH can lead to deleterious effect. The person can go into coma, the person can convulse depending on the individual biological makeup. So this table also goes further to show us pH of different systems. pH 1, that's an acidic, strong acidic pH. That's HCl, that's the gastric juice. What does gastric juice mean? The juice we found where?
Stomach.
Thank you. Now, at pH 4.5 to 5, this also still acidic. You have the lysozymes. What's the lysozymes? Those are enzymes. Lysosomes. No, they are not enzymes. Lysosomes are found on the skin surfaces. Now, at pH 6 to 7, weak acids. I hope you still remember your pH scale. Do we still remember our pH scale?
Yes.
Yes, ma'am.
Okay, so I'm still making sense to you at this point. So at pH 6 to 7, you have the weak acids, and that's the pH of the urine and the cytosol of some cells. Now, the neutral pH is between 7 and 7.4, and that's the pH of the blood plasma and the cytosol. And from 7.5 to 8, you have the weak base. That's the pH of the intestinal fluids and the pancreatic fluid. The pancreas. What hormone is found in the pancreas? Who can remind us? That's where you have your what? Your insulin,
Insulin.
and your glucagon. Yes. So that's the pH of the pancreas is basic, weakly basic. And now you have some strong basic. That's between pH 10 to 12. And these are some pH of some cleaning agents, not physiological, but they are used as cleaning agents. Okay. Now this is
What
where
physiological mean?
this is where I was coming to. Sorry. Now I want us to do this exercise. This is the first quiz. It says if the pH of blood drops to 7.2. I told you to take note of that formula up there. If the pH of blood drops to 7.2, what is the hydrogen ion? And how does this compare to normal pH 7.2? Did you write down the formulas where we are at the formula part? Let me go back to where the formula is. Please take a snapshot of this question so that I don't not keep I'll not be scrolling back and forth. Everybody, please take a snapshot of the question. I'll be taking a snapshot so that I can go and show you where the formula is. And
Yes, ma'am.
you've taken a snapshot. I want to scroll up to where the formulas are. Do I scroll back up now? Are you ready? Should I scroll back up or you still taking snapshots?
That's cool, man.
So this is the first quiz. Now this is the formula you have to use. And I'll just give you another 3 minutes. The first exercise, I did not see anybody's response. Please send your response to the group chat. Just the answer. You don't need to repeat the question because the question is already part of the material. So by 7 o'clock, we'll continue. Let's go to this. Let's see how many people are on Zoom. I'll be on YouTube. Please, those of you on the YouTube link, post your answers to the group chat. I will get them. I will grade them from there. This is the second classwork we are given for this exercise. We have just 1 more minute. Is the time too short? Is the time for the exercise too short? How many of you have finished? Let me go to the chat box so I can see 99 questions. Somebody has posted Oyedele 1.8. That's what you got. Everybody's getting 1.58. Okay, so let's continue. Let's just give 1 more minute for those that are still. Don't just send the answer. I need to see working. Somebody posted 1.5, and everybody is now only the people that have showed out the work is going to get the answer. It's going to get the full mark. You're just posting 1.58 because somebody has shown 1.58. You did not show workings. Somebody has 16. Is this 6? Okay, you approximated. Okay, our time is up. Let's continue. So if you are right, you will know. If you are wrong, you will know. So we said the activity says if pH of blood drops to 7.2, what is the hydrogen ion? And how does this compare to normal pH? So those of you that have 1.58, you are correct. at pH of 7.4, hydrogen ion equals to that, equals 10 raised to the power minus 7.2, which is equals to. So that's the working day. So if you got 1.58, if you sent 1.58, you're correct. So that's so much for water. It's a universal solvent, and we've shared one or two other points on its properties. Now we'll go headlong to proteins. Yes, I'm talking about proteins. And proteins are called the molecular machines of life because of their building blocks. What is the building block of protein? Who can tell us?
Amino acid.
Amino acid.
Thank you. Or they are yes, thank you. So amino acids are the building block or the smallest units of proteins. And there are 20 amino acids, 10 of which are essential, 10 of which are, we have, how many are essential? But heal MP. 10 are essential, 10 are essential. Now, who can tell us why do we call them essential and non-essential? Why? Why do you think they have those tags? Why are they tagged essential and non-essential?
Because they are produced by the body.
Which of them?
Essential amino acids. Essential amino acids cannot be synthesized by the body, so they need to be gotten from external sources like the food you eat and your diet. While non-essential amino acids are already produced by the body. Thank you.
Okay, thank you. Evangel, thank you. So because of the nutritional components, that is why they are tagged essential. Essential means they are needed by the body for growth and upkeep. And that also means the body cannot synthesize. We don't have the enzymes to synthesize these amino acids. So we need to get them from external sources. And then the non-essential ones, the non-essential means that we have the enzymes to synthesize these amino acids. And then we don't have to get them from external sources. So because and the external sources are from the food we eat. That's and I'll not bore you with biochemistry, but for the purpose of this class, we have 10 essentials and 10 non-essentials. I will want you to list for me the 10 essentials and the 10 non-essentials. Please take note, that's your second assignment. The 10 essentials and the 10 non-essential. We used to have an acronym for it in those days. You had me saying VATHIL MP. VATHIL was a member of parliament, so they use his name and his title. Those are the list of the essential amino acids. So please list them and submit through your course rep. Now, and please, each time you are submitting assignment, submit with the list of people that you collected assignments from. Do you understand? Are the course reps here? No course rep is here. Oh, Lori, are you here?
Yes, ma'am. We are here, ma'am.
Because a lot of you will come to my office telling me you cannot find your when we share your materials, you come back telling me you submitted, but you cannot see it after they shared it. So please, that's why I always say anytime you collect anything from anybody, let them sign on the list. You understand? So we have a list of people that submitted so that we all these back and forth will not be there. Will not be saying maybe your friend collected for you. We'll be sure of who submitted. Please, assignment or whatever I tell you to submit it with a list of those that you collected from. Okay, so thank you. Back to amino acids. We said amino acids are building blocks of proteins, and there are 20 amino acids. There are over 200 amino acids, but the ones needed by humans are 20 out of the over 300 types of amino acids. The ones that are peculiar to us are just 20. Now, an amino acid is composed of a carbon atom at the center attached. A carbon is a 4-valence electron. So on attached to the carbon atom, you have the amine group. And amine, that's NH2. And if it's protonated, it's NH3, which is the way it is seen in the physiology in the biological system. So attached to the carbon atom, you have the amine group, you have the carboxyl group, COOH. What did I say the amine group was again? What's the formula for the amine group?
NH2.
NH2.
Thank you. So attached, and we said the carbon atom is 4-valent. That means it has 4 parts. It has 4 sticks attached to it. So the first group attached to the carbon atom is the NH2. The next is the carboxyl group. It could either be COOH, and if it is deprotonated needs removal of 1 electron, you see COO minus. And then you have the R group, that's the side chain. And the R group determines the function of the amino acid, whether it will be a acidic amino acid, a basic amino acid, a what do they call those amino acids again that can form carbohydrates? A glucogenic amino acid, a ketogenic. The R group is what says what says that what the amino acid will become from the R group. And then the last atom is the H hydrogen ion. So this is what I've been describing. This is what I've been describing. This is what it looks like. This thing should be on C. You can see there are 4. You have hydrogen, you have H2N, you have R, and you have COO. So this is what an amino acid looks like. And this is the classification of the R groups. We said the R group is what determines the type of amino acid we have. Example, if the R group is a non-polar aliphatic, that means the amino acid is called glycine, alanine, valine, as listed. If the R group is an aromatic compound, then that means the amino acid will be hydrophobic, and it will be either phenylene, alanine, tyrosine, or tryptophan. So just as it is in the R group determines the function and the of amino acid. So we have another activity here. Let's see if we can do it. Is there a formula for you to use? Okay. Special case of histidine has a pKa of 6 for imidazole side chain. This is unique among amino acids. pKa. At pH 7, histidine is approximately 75% protonated. I need to see a formula. Okay, we are still using the same formula for pH. Let's continue. I'll let you do this activity when you are reading through. You use it to sharpen your understanding. So let's see essential versus non-essential. So we said essential means must be obtained from diet. Non-essential means can be synthesized in the body. So the ones that are essential are valine, lysine, isoleucine. They are branched and they are all listed here. And the non-essential ones are alanine, and they are all listed. So I'll leave you to know that, because it will come out in course or exam. What are the importance of amino acids? Amino acids, number 1, they are important as energy sources during exercise. That's from the ketogenic amino acid. The ketogenic amino acids form ketone bodies, and in the absence of glucose, the body depends on these ketogenic amino acids. Okay. Also, they are regulators of muscle protein synthesis, like leucine activates COR pathways, which helps in the function of protein is for repair of worn out tissues. Okay, so the mTOR pathway helps to regulate protein synthesis in the body. Take, for example, they say all enzymes, it's often said that all enzymes are proteins. So if an enzyme is needed, for example, and it's not in the body, but the body has the materials to synthesize this enzyme, the mTOR pathway activates leucine, which helps this enzyme to be synthesized. I'm just using that as an example, but that's called biochemistry. I'll not want to bore you with all those details. Now, what is the implication of proteins and amino acids in metabolic disorders? Okay, usually they are elevated in type 2 diabetes. They are elevated in type 2 diabetes. Let me come again. In metabolic disorders, proteins and amino acids are elevated in type 2 diabetes. I'm trying to make sense of type 2 diabetes. What's type 2 diabetes? I need us to understand what is trying to say. What's type 2 diabetes? Anybody have an idea? Nobody. Okay, let me explain. So in type 2 diabetes, the body can produce insulin, but the body cannot use insulin. What do I mean? The pancreas, we said when we're talking about pancreas, pH and pancreas, remember, the pancreas is the organelle that stores or secretes insulin. Let me say secretes. Is the organelle for secretion of insulin. So what happens is that in type 2 diabetes, insulin is produced, and the work of insulin is to mop up. You know, when you pour water on the floor and they say mop the floor, what does mop mean?
Clean.
Great. Clean. You use something that will absorb the water. So the work of insulin is to remove glucose from the bloodstream, because glucose in your bloodstream is poison to the body. Glucose should be in the cells where they are needed, because in the cells is where you have the enzymes that will convert that glucose to energy, which is ATP. The body understands ATP. That's the energy currency of the body. But when this individual keeps on eating and is still feeling weak, most times they'll be treating malaria. But they often say when you've overtreated malaria, check your blood sugar. Because if the insulin cannot remove, the work of insulin is to clear out glucose from the blood into the cells. And how does it do it? Insulin has its receptors on the cell surface. It's just like lock and key. You have the key to the door, you open the door, you enter. But when the door lock is bad, what happens? You enter? No, because the key will not work. It just keeps opening. So that's what happens in type 2 diabetes. In type 2 diabetes, the person has abused sugar. He has abused sugary foods. So what happens is that even though the person can produce synthesized insulin, the cell receptors it's what did I say? It's on the membrane surfaces. It's receptors. The receptors of insulin on the membrane surfaces that will open up the cell so that glucose will come into the cells is weak. Insulin is trying to unlock the receptors, but the receptors are not, they've been overworked, they've been over a period of time. That's why they also call type 2 diabetes lifestyle disease. So what happens is that they can produce insulin, but the insulin is not working. That's why they have to give them injections that will mop up, remove the glucose from. Because if this glucose is in the blood, they will just be collecting anywhere they see. They can start collecting in the eye, the people go blind. They can start collecting in the joints, the person start having arthritis. You understand? But when insulin is allowed to clear out the sugar from the blood, then they go into the cells and the person will eat and will have energy to work. So that's the meaning of the implications of proteins in metabolic disorders. They are often elevated during type 2 diabetes. So let's go to the classes of proteins. Proteins are classified based on composition, shape, and function. We have the simple proteins. Let me come again. We said proteins are classified based on three things. What are the three things I just mentioned? Am I the only one in this class? Thank you. They are classified based on composition. What does composition mean?
What made of?
Ma?
What is what?
I didn't hear you. I did not hear you.
Composition means what they are made of.
The components, yes, thank you. That is whether it's a ketogenic amino acid joined to acidic amino acid. So what they are made of. So proteins are classified based on their composition, their shape, and their function. So you have simple proteins. Simple proteins is just a polymer of amino acid. Polymer means so many amino acids joined together. Monomer means one. Poly means plenty, 50 and above. That's the protein. Once the amino acids combine together at 50 and above, then it's called a protein. But if it's less than 50, it's just called a peptide. So you have proteins, that's a simple protein. So, and these are the classes. You have the albumins, globulins, and glutenins, prolamins, skeptoproteins. So classes of simple protein is what you can see in this table. And this type of proteins are found in the blood. Are they in the blood? Albumins, yes. Albumins, they are water soluble. They are found in the serum and in the albumin. Globulins, you have the immunoglobulins. You remember immunoglobulins? Those are like the soldiers. Those are seen in the white blood cell. The hemoglobulins are the body soldiers of the body. That's why you don't always have to use medications. Sometimes if you just rest, if you're tired and you just rest, you'll be okay. So because the body too has soldiers that fight all these invaders. Glutelins. These glutelins from gluten is seen in wheat, and you have prolamins. And the point is just that all these simple proteins, they are simple proteins made up of only amino acids in a straight chain. Then the next is the conjugated proteins. The conjugated proteins contains non-protein prosthetic groups. A prosthetic group is, what if somebody has a false arm, those people that have only one hand, what do they call those things? If they have a hair, so it's just the same thing, it's just the same meaning here. A prosthetic group is a non-protein group attaching to it. Take, for example, a glycoprotein contains carbohydrates chains plus amino acids. That's why it's called a prosthetic group. A glycoprotein has carbohydrates, and we see that also in immunoglobulins. Lipoproteins contains lipid plus amino acids, and we see that in the LDL, HDL, and they are used for lipid transport. So the list is endless. Abi, the list is self-explanatory, so I'll not go through it chronologically. I'll just pick one or two just to make it. So the last point here says metalloproteins. Metalloproteins means metal ions plus amino acids. And you have ferritin. Ferritin shows us that it has to do with blood or carbonic anhydrase. That's zinc. These ones are storage proteins. Okay. This is talking about the lipoproteins. The lipoproteins, they have an amphipathic shell. Who can try? What does amphipathic mean? Amphipathic.
Can behave as a base and an acid.
Thank you. Great. You are correct. So they have both acidic and basic properties, and they are also phospholipids. So the lipoproteins, they are transport proteins, and we have four classes. Some say five, some text say four, some text say five. But the most important is to know which ones are the lipoproteins. You have the chylomicrons. These are very dense. They have very dense. You can see the density. This is less than 0.9, and they originate from the intestine. Then you have the VLDL. VLDL means very low density lipoprotein. Please write it in your jotters. Very low density, or your notebooks. Very low density lipoprotein. Please take note of also the functions, because you see some text saying some are bad fat, some are good fat. So the chylomicrons, they deliver fats. I told us that they are fat transporters. They take fat delivery to the tissues. That is, they take fat from the intestine and put them on your tissues. That's why there's some people you can see they keep on blowing up. When they overeat, they keep on getting bigger and bigger and bigger. Now the VLDL, they originate from the liver, and they also take fats from the liver to the tissues. Please note, because I'll ask you a question at the end. Should I start from the beginning, or I should continue of the chylomicrons?
Now start again.
Okay, because this question you answer it in the group chat. I said the chylomicrons, they originate from the intestine, and they take fats from the intestines to the tissues. And I said that's why some people blow up when they overeat, because the excess food is always converted to fat and stored. So instead of storing it in the liver, it's stored in the tissues. That's the chylomicrons. Now, the VLDL is also similar to the chylomicrons. It's just that it's coming from a different location. It originates from the liver, but it also sends fats or triacylglyceride. TAG means triacylglyceride. It sends TAGs to the tissues. Now, LDL delivers cholesterol to the tissues. That's why it's called the bad fat, because cholesterol in your tissue will give a lot of problem. It can block the arteries. It can do so many havoc. But LDL catabolizes VLDL and it stores the cholesterol in the tissues. While the HDL transports cholesterol from the liver, from the tissues to the liver. HDL is in the liver and in the intestine. It reverses cholesterol. So it takes it from the tissues to the liver so that the liver can destroy it and it will be expelled out of the body. So the clinical relevance of this is that LDL, like I said, penetrates artery walls, initiating an atherosclerosis. That means when LDL keeps on depositing fats on the artery walls now become very hard, rigid. The arteries are very flexible, like rubber. You've seen rubber band before now. We've seen rubber band, especially the females. We use it to pack our hair. Abby, the arteries walls are that soft and spongy. But when you have fat being deposited on them, they now become very rigid and they can break. And once that happens, that's why people get stroke and different diseases, different cardiovascular problems. Because once an artery should break, depending on where it breaks, the person can even die if care is not taken. So that's the clinical relevance of all these classes of transport proteins that we are looking at. So that they say the body is garbage in, garbage out. You are what you eat. If you eat right, your body will be healthy. If you don't eat right, your body will process what you feed it with. So these LDLs, the question I want to ask us now is, number one, right? Are we hearing me? The classes of lipoprotein. What are the classes of lipoproteins? And from the classes of lipoprotein, which one is the good lipoprotein? Which one is the bad lipoprotein? Did you get the question? Hello, are we there? I've been logged out.
Yes, Mama. I can hear you.
We are here, ma.
So I said just one in one line. The classes of lipoprotein, which is the good, which is the bad. No too much, no too many stories. Send your answers in the chat. And I think we should be concluding our class. I've spoken for 1 hour. So for today's class, we'll just stop with proteins. We'll continue with the other macromolecules in next class. Have we filled the poll? Have we been able to fill the poll?
No, ma.
It's not yet been launched.
I don't see anything.
While you are responding to that question, I will launch the poll for today's class.
Sorry, ma. Good evening, Mama. Please, I don't see any polls.
I just said I will launch it. I will launch the poll for today's class while you're supposed to be responding to the question that was asked. Today is 3rd of July. And I'll not let it I'll just give you a few minutes to respond. So I've launched a poll now. Please make sure you fill in your details. We have just 1 more minute to do the.
But what of those on YouTube? How would they send us one?
It's being recorded. The YouTube is being recorded. So I'm seeing once they are logged in with their what's the name? They are logged in with their name and their matric. Or maybe they should send their departments to let them send their department. I'm sure they are hearing us. They should send their department so that one will be, but with the matric, I can know the department. But let them just send their name and department to the group chat. And then that's number one. Number two, the classworks we are doing. It's also a means of attendance. There's so many top chats here. I can see so many people saying both nursing or chemistry, MLS. Okay, so let me continue. So we said according to shape, you have fibrous proteins, you have globular proteins. Fibrous proteins are those that are keratin. Keratin is found where? Who can tell me?
The skin.
In our
Hey,
nails
lie.
and in the hair.
The skin, ma.
Yeah, here, keratin is the proteins in your hair, not the skin. Keratin is very hard. If it's the skin will be cracking. It can never be the skin. It's the protein found in the hair. You can see how strong the hair is. That's keratin. The skin, please be corrected. Then collagen. Collagen is found where?
The skin and nails.
Ah! Oh my God. No. Keratin is nail. Keratin is nail. Once you see hard, something hard. Keratin is nail and hair. Collagen is your ears. Yeah, you can see your ear. Your ear is not soft, it's not hard. I don't know what to call the texture, but you can see your ear now. That's what do they call that outer ear? What do they call it? It's made of keratin. It's made of collagen. Collagen is brittle. Now, globular proteins. You have globular proteins. Examples are enzymes, antibodies, albumin. I touched on albumin initially, and then you have membrane proteins. Those are the channels and the pumps and receptors. You remember when I was explaining insulin, I touched on this. So the receptors are also membrane proteins. Okay, collagen is the most abundant protein in mammals. About 30% of the total protein mass in mammals is collagen. Okay, then you also have structure, according to structure. Classification according to structure, you have the primary structure, secondary structure, tertiary structure, and quaternary structures. And depending on how the folding is what determines whether the primary is linear, that means one strand. Secondary is helix, three residues pattern. The tertiary structure is a triple helix, and the quaternary is the staggered array with cross links. Okay, so the mechanical properties, the tensile strengths. Let me just go to the next topic. The properties of proteins, physical properties, solubility determined by pH relative to pI. What is pI? I said 2 points. That's the meaning of pi. Any questions so far? I've been speaking for 1 hour. By now, I should have harvested questions. Any questions for Miss? Please. Any questions? You all understand 100%. It's not possible. The people on YouTube, any question? How many people are here? Let me see. Are we together? The people on YouTube, are you following? Please respond in the group chat. Is that yes or no? So like I said, I'll be stopping up with proteins and we'll continue next class. Okay, I following. Thank you. I can see yes, ma'am. Yes, ma'am. So any question? And water, we started with water. We talked about ionization energy. Ionization energy. What again did we talk about on water? What's that shell? Hydration shell. The properties, chemical and physical. What again? Now, then we came to proteins. Proteins, we are talking about the properties, the types, etc. So those are the physical properties we've talked about. Now let's see if we can conclude with the chemical properties. So the chemical properties of proteins, they are amphoteric in nature. What does that mean? Okay, we said they have both acidic and basic behavior. They have pK 2.5 and also pK of 9.0. Okay, so you have the chemical properties, they are amphoteric in nature. That's one. Let's go to two. Their reaction. They react with copper sulfate in an aqueous solution to form peptide bonds, which gives off a violet color. And then also they react with nitrogen and heat to release amino acid groups. Also, you have the Millions reagent. You remember the practicals we did in first semester? Those of you that took 203. You have the Millions reagents giving a red precipitate in presence of phenolic group. So these are the chemical reactions. They react with various compounds, especially the Biuret reaction. Is like the signature reaction for proteins. The Biuret reaction. They react with copper to form. Now the denaturation. Denaturation is another chemical property of protein. And they say once a protein loses its structure, it loses its function. So what does that mean? A protein moiety, a protein substance is denatured at 40 degrees Celsius. Please take note. You remember egg. How many of you have fried egg before or you boiled egg? That's just the best example I can of the denaturation. Have you ever seen boiled egg before? Anybody seen boiled egg before?
Yes, ma.
So before the heat was applied, what was the state of the egg? Was it liquid or solid? In raw form, egg is in what state? Liquid or solid?
It's in liquid, ma.
Okay.
Liquid, ma.
So that's what denaturation is all about. Because of the heat, it became solid. So that's, we say once a protein loses its shape, it loses its structure, it loses its function. So proteins can be denatured by heat, they can be denatured by extreme pH, they can be denatured by organic solvents, and the list goes on. And this formula, the thermodynamics of denaturation, says, helps us to know the enthalpy change, if it's negative, or if the reaction is going forward or backwards. The denaturation is often sharp because unfolding of one region stabilizes adjacent region. And once a protein is denatured, it loses its function. Now, the function of the protein, you have catalysis. We say all enzymes are protein, but not all proteins are enzymes. So catalysis. And a catalyst is what speeds up the chemical reaction. A catalyst speeds up a chemical reaction like 1 million times faster. An example is, if you were to trek from your hostel to science, those of you in Idiaraba, if you were to trek from Idiaraba to science in Akoka, or you were to use transport, which one would be fastest?
Transport.
Great. That is exactly what a catalyst does. It speeds up a chemical reaction 1 million times faster. If you were to trek down, it will take you days. Some of you will even start in some people, it won't take them 1 week because they don't trek. They don't they some of you, you've never done that type of work before. Some of you, it will take you maybe the whole day. It will start from there by in the morning. If you know some shortcuts, you'll get there in the evening or in the night. But a catalyst speeds up the reaction. So all proteins are enzymes. Know that one. So those are the function. Number one, catalysis. Where is the table? I can't find the table again. Oh goodness. Let me look for the table. Okay, so the next one is transport. Hemoglobin transports oxygen all around the body. The lipoproteins transport fats all around the body. Then you have structural property. They provide chemical support. That's collagen. We said 30% of body is collagen, of the body protein is collagen. This serves as connective tissues. And they also are okay, the cartilage. Oh, the protein in the ear is not collagen, no, it's cartilage. It's called cartilage. Sorry for misleading you. So the collagen serves as connective tissues within the muscles. And you also have keratin. Keratin is a structural protein. That's the protein in the nail and the hair. And also elastin. So why does this keep moving? I would like to stop here at the functions. At the function of protein. Okay, you see the function in movement, in defense. That's the immunoglobulins. The immunoglobulins are the antibodies. And also regulation. That's the transcription and storage. So we stopped at the functions of proteins. And I'll see you next class. Any questions for me? Please, if there are no questions, respond. If there are questions, have them. We're not responding. That means silence means
Ma'am,
okay. You have a question. Somebody was saying something just now. I mean, is person logged out? Okay, in the absence of any question, I think we should call it a day. It's been a long day today. So let's all on mute and share the grace. We'll meet next class. Same time next class, please. And I'll be
Thank you
on
very
mute.
much.
Before we all I'll explain to us why our class is by this, because this is the time everybody can agree to meet. Before now, people are coming with different excuses. We have class, we have this, we have practical. That's why the class has to be in the evenings, because this is the time when all the other classes would have ended. And I hope nobody will come up, even if it comes up with any excuse by this time, then I don't know what we will do. Maybe we'll just have to excuse that department. Because I'm stretched. I've had it. I still have to come for this lecture. Okay. So any other question? Okay, please let's all unmute and share the grace. May the grace of our
The
Lord
grace
of our Lord
of
Jesus Christ,
Praise
Jesus
the
Christ,
Lord
love
Jesus
of
Christ,
the
God,
love
the
of
love of
God,
God,
the
the
sweet
and
sweet
the
fellowship
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 of the
of
Holy
the
Spirit
Holy
of
Spirit,
us
be
be
now
with
and
with
us
us
now
now
forevermore.
and
and
forevermore.
forevermore.
Amen.
Surely,
Amen.
His salvation shall
God's
follow
goodness
us
and mercy shall
all
follow us
days of our
all the
life,
days
All
of
and
our
we
days
shall
of
life,
dwell in
our
the house
life,
and
of
we
the
shall
Lord
dwell in the
forever
house
and
of the
ever.
Lord forever and
Amen.
ever. Amen.
thank you for your time. See you next class. Bye.
good night, everybody.
Thank you.